Well, HBM stands for high bandwidth memory. And the first thing that you could see is different from normal memories is that we've gone 3D. We're stacking chips on top of each other, so we actually are going up, not just across the XY dimension. This really changes everything because now we have silicon to silicon interfaces. When we use silicon to silicon interfaces, we can use very, very high density interconnect. GDDR5 is narrow and fast. HBM is wide and slow. Compare the bandwidths, massive delta in bandwidth, 4x, because we've basically gone very, very wide. When we combine the memory with our SoC, we're going to place it also on a piece of silicon, which allows us to move everything very, very close together. Now we get two effects. One, we get power. Power reduces radically. The second thing is we moved everything very close, so now we can build very, very small form factor devices. So we have low power, small form factor, and this allows us to build things that really have never been done before. It started 7 years ago. We recognized we had two problems to solve, power and form factor. And so we pulled a team together within AMD, some great engineers such as Brian Black, who's really one of the more courageous folks that I've met, and that he's put so much of his professional life into solving the die stacking problems. But we had to bring in others. It wasn't just AMD. We needed to bring in partners from the memory industry, such as Hynix. We needed to bring partners from the packaging industry, interposers, UMC, Amcor, ASE. All these folks needed to come together. This was not a simple task. There were so many unforeseen challenges. And, it's just so beautiful when you see multiple companies, great engineers such as Brian, all coming together, knocking the problems down one by one, and it's amazing. 7 years later, we actually have HBM, and it's going to change your lives, just as it is, changing my view of what I can build in this world. Well, we start with consumer graphics. It's a poster child for high performance and great experiences, and HBM, fits that beautifully. You might ask yourself, well, games today are already so beautiful. Why do I need them better? Well, tomorrow we have virtual reality coming. It puts more pressure on the entire system than any other application we've seen. To achieve the levels of performance needed for a full virtual world, full interactivity, full presence, you really need an HBM memory in order to power the system. But it doesn't end there. If we look into the server space, the high performance compute space, vast applications for HBM there. High performance compute is all about memory bandwidth and compute capability. You really have to scale those equally, and HBM will allow us to build high-performance computers, supercomputers, like no one has ever seen before. In the server space, we have huge challenges. We keep increasing cores, we put more pressure on the memory subsystem. HBM can help us solve those problems. In the communication space, high-speed switches, HBM applies. Pretty much across the whole continuum of compute, I believe we'll see HBM or HBM-like devices really attack those problems and enable things that we just can't do today.